Okay, so we've gone through and calculated Molly's opportunity cost for her farm. But you may have realized Molly doesn't have to choose either carrots or spinach. She can choose any combination. So let's go through and examine a range of crop choices she can make. First, let's set up her farm as rectangular lot. And this is just for simplicity. We could use really any shape we wanted. In addition to the rectangular lot, let's use an XY graph to plot how much of each crop Molly's harvesting as we move through this model. And let's use the vertical axis to represent her carrot harvest and the horizontal axis to represent her spinach harvest. We've already established that if she spends all her time growing carrots, she can harvest 5 tons, and spinach 45 tons. So let's plot those as the two extremes on the positive worth end. Then you might be wondering, what if Molly decides to plant some other combination other than the two extremes? So let's use, for an example, her planting half and half. So she plants carrots on half her land, and she plants spinach on half her land. So to find how much of each crop she's harvesting, we would take the 5 tons of carrots and cut them in half, and then we take the 45 tons of spinach and cut them in half. And we can plot that on our XY graph. You might be wondering now how Molly would choose how much of each to plant, and we'll come to that in later sections. But for now, we're just going to find what's possible and think about the trade-offs involved. So after she's planted half and half, and we've gone through and plotted this on our XY graph, let's pick a couple more points. So let's say she decides to plant 2/5 on her land. So we're going to divide her land into 2/5 both directions. So first we'll plot. So now that we have 5 points on our graph, we can start to see a relationship come into view between Molly's carrot and spinach harvests. And we can go through and calculate the slope of this relationship. And guess what? It turns out to be opportunity cost, 1/9. We can already start to see that opportunity cost is essential in how Molly thinks about her planting decisions. As we shift land away from carrots to spinach, we give up 9 units of spinach per unit of carrot. Or the other direction, as we shift land away from spinach to carrots, we give up 1/9 unit of carrot per unit of spinach. So this is what we call the production possibility frontier. And we're just going to use PPF because production possibility frontier is too much to say. So as we move along the PPF, we're giving up one good to gain more of the other. This is really the trade-off captured by the opportunity cost, and it's embedded in this relationship as we mentioned earlier. So you might be wondering at this point, does the PPF represent every possible harvest combination Molly could choose? And if your intuition is telling you no, then you're right. Let's say one year Molly overslept and she didn't have enough time to plant one corner of her farm. And let's say this area of the farm is 1/5. Then let's look at what happens if Molly would split the remaining land equally between carrots and spinach. So you can notice this is inside the PPF. This is not on the frontier. This is inefficient, right? Since there's productive land that's gone unused. You might be thinking that maybe she had a good reason to leave it unused, and yes, sleeping is certainly important. And we'll get to how Molly chooses how much of each crop to plant later in the semester. But just for the moment, all we can say is that there is missed potential in her harvest. So you might be wondering, like, what if Molly had sort of realized that there was a PPF involved in her planting decisions? She realized she faced a PPF and wondered how she could do better. And if you were asking this question to yourself, it's a good one. And that's exactly what the next set of videos will be talking about.